Are you looking for a video tutorial about maxima and minima, time rates, and another application of differentiation? If that's so, this video is for you. I am ROYALLENE from BSED 3D, and this is my performance 1 in Calculus 2. So, what are we waiting for? Let's start! Let's start with maxima and minima. The problem for maxima and minima is find the maximum and minimum points of the following points of the curves. Y is equals to 3x squared minus 18x plus 6. First, let's get the derivative of the given, and the derivative of y is equals to 3x squared minus 18x plus 6 is y prime is equal to 6x minus 18. Then at a critical point, let y prime is equals to 0. So we have 0 is equals to 6x minus 18. Then let's transpose positive 6x to the other side, so it becomes negative 6x equals to negative 18. Then let's divide both sides by negative 6, so we get x equals to 3. Then now that we have the value of x, we will substitute it to the given to get the value of y. So we have y is equals to quantity of 3 squared minus 18 times quantity of 3 plus 6. Then combine similar terms. Negative 18 times 3 is negative 54. Then simplify it. 3 times 9 is positive 27. And negative 54 plus 6 is negative 48. So we have y is equals to 27 minus 48. Then our y is equal to negative 21. That's why we have positive 3 and negative 21. So now let's check the critical points, if it is minimum or maximum points. Using the first derivative test, let's get the value of the left and right side of the x, which is 3. Let's use x equals to 2 for the left side and x equals to 4 for the right side. Let's use first x equals to 2. Let's substitute the x in the first derivative, which is y prime equals 6x minus 18. That's why we have y prime is equals to 6 times 2 minus 18. Then 6 times 2 is 12. That's why we have y prime equals to 12 minus 18. Then 12 minus 18 is negative 6. That's why y prime equals to negative 6. Then now let's go to x equals to 4. Let's substitute the x in the first derivative, which is y prime equals to 6x minus 18. That's why we have y prime equals to 6 times 4 minus 18. Then 6 times 4 is positive 24. That's why we have y prime equals to 24 minus 18. Then 24 minus 18 is positive 6. That's why we have y prime equals to positive 6. Then compare the sign of y prime. Since y prime changes sign from negative to positive, the point positive 3 and negative 21 is minimum. Let's go now to time rates. Our problem in time rates is water flows into vertical cyclical tank at a rate of 45 cubic feet per minute. If the radius of the tank is 5 feet, how fast is the surface rising? First, let's make a figure, and we know that the given are the radius, which is 5 feet, and 45 cubic feet per minute is our derivative of volume with respect to time. So our figure would be like this. Then let's proceed to our second step. Our working equation is volume of cylinder equals to area of the base times height. And we know that the area of the base is pi r squared. So we have volume of cylinder equals to pi r squared times height. Then if our radius is equals to 5 feet, then we have the volume of cylinder equals to pi quantity of 5 squared times height. Then simplify it. That's why we get volume of cylinder equals to 25 pi times height. Then let's proceed to the last step. Let's differentiate it. That's why we have derivative of volume with respect to time equals to 25 pi times derivative of height with respect to time. Then let's divide both sides by 25 pi. 25 pi divided by 25 pi is 1. That's why we get dv over dt over 25 pi equals to dh over dt. Then now, let's substitute the value of derivative of volume with respect to time. That's why we have derivative of height with respect to time equals to 45 over 25 pi. Then simplify it. That's why we get the final answer, which is derivative of height with respect to time is equals to 9 over 5 pi feet per minute. For the last part of this video is another application of differentiation. The problem of another application of differentiation is find two positive numbers whose product is 36 and whose sum is a minimum. Given that the product of two numbers is 36, let x is the first number, y is the second number, and s is the sum of the two numbers. Our quantity to be minimized is the s, which is the sum of two numbers. So our working equation would be s is equals to x plus y. To express the equation in terms of single variable, use the other given, the product. So we have 36 equals to x times y. Let's divide both sides by x. X divided by x is equals to 1. That's why we get y is equals to 36 over x. Then our working equation will become s is equals to x plus 36 over x. Let's differentiate it. That's why we have the derivative of s with respect to x equals to 1, which is the derivative of x plus negative 36 over quantity of x squared multiplied by x. We have negative 36 over quantity of x squared multiplied by x because we applied the derivative of constant over a variable, and we know that it is equal to negative c over v squared times derivative of v. Let our c is equals to 36 and v is equal to x. Simplify it, so the derivative of x is 1. That's why we have derivative of s with respect to x is equals to 1 plus negative 36 over x squared multiplied by 1. Then simplify it again, and we know that the positive times negative is negative. That's why we have derivative of s with respect to x is equal to 1 minus 36 over x squared. We're going to set ds over dx, or derivative of s with respect to x, equal to 0. That's why we have 0 is equals to 1 minus 36 over x squared. Then let's transpose negative 36 over x squared to the other side. That's why we have positive 36 over x squared equals to 1. Then cross multiply. That's why we have 36 equals to x squared. So for the unknown, let's solve for the value of x. That's why we will get the square root of both sides. So we get x is equals to 6. To solve for y, we will use the equation y is equals to 36 over x. Let's substitute the value of x into 6. That's why we have y is equals to 36 over 6. So 36 divided by 6 is 6. That's why the value of y is 6. Thus, the two numbers are 6 and 6, whose the product is 36 and whose sum is minimum. For checking, we will use the equation 36 is equals to x times y. So, the x is equal to 6 and y is equal to 6. Then, let's plug it into the equation. That's why we have 36 is equal to 6 times 6. 6 times 6 is 36. That's why we get 36 is equals to 36. It shows that 6 and 6 is the correct answer. Thank you for watching, math learners. Once again, I am Faith ROYALLENE BOLISAY from BSED 3D, and let's bear in mind that every problem has its own solution. Thank you for watching.